A fly ate livestock alive. The United States declared war on it. They used nuclear radiation to win. By the end of the campaign, scientists would release billions of sterile flies and erase the parasite from an entire continent. There is a fly called Cochleomya hominivorax. The name is Latin. It means man-eater. The people who named it were not being dramatic. The screwworm fly looks ordinary enough. It is roughly the size of a housefly. It has iridescent blue-green wings. It could pass unnoticed in any meadow in the American South. But the female does something unusual. She lays her eggs in wounds, open cuts, tick bites, navels of newborn calves, surgical incisions. Any breach in warm flesh will do. The larvae hatch within hours. They do not eat dead tissue. They do not scavenge. They eat only living flesh, burrowing inward, drilling in a corkscrew pattern that gives them their name. A single infestation, untreated, can kill a full-grown steer in 10 days. The animal does not die of the wound. It dies of the excavation. And here's the part that tends to stay with people. If you leave an infested animal in the sun, you can sometimes hear it. The United States Department of Agriculture confirmed this in field reports. Nobody writes that in the brochures. The screwworm was not a nuisance. It was an industry-scale catastrophe waiting to happen every spring. By the mid-20th century, the screwworm had spread across the American South, the Southwest, and into the Caribbean. In a single bad year, 1935, it killed approximately 1 million livestock animals in the American Southeast. The economic damage ran into the tens of millions of dollars. Farmers inspected their herds daily. They smeared wounds with chemical treatments designed to repel the flies and kill the larvae. It worked, partially, some of the time. The fly was adaptable. It reproduced quickly. A female could lay up to 400 eggs at a time. Standard pest control math did not apply. You could kill 90% of the population and still have a catastrophic infestation the following week. Something different was required. The existing tools were not inadequate. They were the wrong category of tool entirely. In the 1930s, a USDA entomologist named Edward Knipling noticed something strange. Female screwworm flies mate only once. Once. That meant one mistake could end an entire bloodline. Most insects mate repeatedly. The screwworm did not. And Knipling concluded that this single biological quirk was an exploitable vulnerability. The idea was this: introduce large numbers of sterile males into the population. Males that were otherwise healthy, that flew and competed and mated normally. The females who mated with them would produce no offspring. Do this at sufficient scale, and the population collapses. He called it the sterile insect technique. His colleagues were polite about it. They did not fund it. For roughly a decade, the idea sat on paper. The theory was correct. It simply needed a way to sterilize millions of flies without killing them. The 1950s were the golden age of nuclear optimism. Radiation was being explored as a solution to problems that had nothing to do with weapons. Medical treatments, food preservation, agricultural applications. Knipling and his colleague Raymond Bushland recognized that ionizing radiation could sterilize insects without killing them, if the dosage was calibrated correctly. Too little, fertile flies. Too much, dead flies. The correct dose rendered a male fly permanently sterile. His wings still worked. His mating drive remained intact. He was, from the perspective of a female screwworm fly, entirely indistinguishable from a fertile male. In 1954, a field test was conducted on Sanibel Island off the coast of Florida. The island was isolated. The screwworm population was known. Sterile males were released in calculated numbers. Within months, the local population collapsed. Not reduced, collapsed. The island was screwworm-free by the end of the trial. The island was the proof of concept. What came next was an industrial operation. The eradication campaign for the American Southeast began in 1958. Imagine a factory whose only purpose was producing flies. Then imagine another, and another. At full operational scale, America was releasing nearly 2 billion sterile flies every week. More flies than there were people on Earth at the time. They were irradiated as pupae, packed into cardboard boxes, and dropped from aircraft across target areas. The technique does not kill the existing population directly. It dilutes it, generation by generation, until the population can no longer sustain itself. By 1966, the screwworm had been eradicated from the continental United States. Declared, officially, gone. A parasite that had been part of American agricultural life for as long as ranching had existed. Gone. Nobody had done this before. Nobody had eradicated an insect species from a continent using only other insects. Eradicating the screwworm from the United States created an immediate problem. The fly still existed in Mexico, and Mexico shares a long border with Texas. The screwworm does not check documentation. A joint U.S.-Mexico eradication campaign began in the 1970s. Then the campaign moved into Central America, one country at a time, working southward. Mexico was declared screwworm-free in 1991. The goal was to establish a permanent biological barrier at the narrowest point of the landmass, the Darien Gap region of Panama. A sterile fly barrier maintained along this line requires a continuous release program. The moment it stops, the fly can re-enter from South America, where it still exists. Central America was not freed from the screwworm. It is kept free from it, indefinitely, by an ongoing operation most people have never heard of. In the autumn of 2024, the screwworm was detected in Florida. Not a single animal, an outbreak. The United States declared an agricultural emergency and suspended live cattle imports from Mexico. The screwworm had not been absent from Florida for 6 decades and then spontaneously reappeared. It arrived. The sterile fly release program, still operational after more than 60 years, was redeployed. The outbreak was contained. The solution to the 2024 outbreak was the same solution developed in the 1950s. Not an improved version, the same technique, applied with modern logistics. It still works. The screwworm returned. The nuclear flies were still waiting. A fly that eats living tissue. An industry crippled for decades. A scientist with an idea nobody wanted to fund. Radiation used not as a weapon, but as a scalpel. 2 billion sterile flies dropped from aircraft every week. An entire species pushed off a continent. Not aliens, not suppressed technology, not a conspiracy. Edward Knipling, a calibrated dose of radiation, and an enormous number of infertile flies. If you want more stories like this, subscribe to World of Why. Somewhere in Panama today, aircraft are still releasing sterile flies, not because the war is over, but because it never really ended.